molecular compounds form when nonmetal atoms share electrons. Here, hydrogen and oxygen are sharing electrons to get a stable octet for each of them. Two nonmetal elements can combine in a lot of different ways. Nitrogen and oxygen, for example, can combine as NO, NO2, N2O, and so on. In naming molecular compounds, we have to explicitly tell the number of atoms of each element using prefixes because they can do this, because they can combine in multiple ways. Naming molecular compounds, then, entails naming each element, the proper prefix added, and then using the IDE ending. Make sure that you know the prefixes for 1 through 10, and make sure you can spell them correctly. The prefix for 1 is mono, 2 is di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Again, make sure you know those 10 and make sure you know how to spell them correctly. Here's 2 examples. On the first one, we're going to name the element N, which of course we know is nitrogen. On that, we're going to put the prefix for 2. That prefix is di. Then we're going to do the same thing for the second half. We're going to put the prefix for 5. That's the prefix penta. And then we're going to name the element O. We're not going to use the whole name for O. We're going to use the ending IDE on it, so that's going to turn into oxide. We're always going to use the IDE ending for molecular compounds. The second example, P4O10, same thing. We're going to use the prefix for 4, the name for the element P, the prefix for 10, the name for the element O, again with the IDE ending. Putting all that together, you get tetraphosphorus decaoxide. Remember that the prefix is omitted in one condition. When there's only one atom of the first element that's listed, the mono prefix is left off. So CO2 does not start with the mono prefix, it is just carbon dioxide. The second element, on the other hand, must always have a prefix, including when it's the mono prefix. So N2O, for the second element, there's only one of them. You do use the mono prefix. This is dinitrogen monoxide. Try these examples. Figure out the names for the 3 formulas that are given, and try to write the formulas for the 2 names that are given. If you need some time, pause the video, try them, and then turn it back on when you're ready. Since all of these are molecular, we're using prefixes, names, and the IDE ending. For this first one, SF6, the first element, there's only one of them, but we don't use the mono prefix, so that's just going to be sulfur. And 6 Fs means hexafluoride. N2O3 becomes dinitrogen trioxide. PCl, we don't use the mono prefix for the P. We have to use the mono prefix for the Cl. So we get phosphorus monochloride. For the 2 names down below, you're doing the same thing, just in reverse. Since this first one doesn't have a prefix on the word oxygen, that means there's only one of them. And then it says difluoride, so that means we have 2 fluorines. So that formula is OF2. Lastly, dinitrogen triiodide. Be careful reading this one. For whatever reason, when it's that iodide on the end, people love to skim over it, I guess, think that it's oxide, and so they use oxygen instead of iodine. Watch out for that and make sure you don't fall into that trap. Dinitrogen triiodide is N2I3.